Assalamualaikum warahmatullahi wabarakatuh. I be to Nathan. Okay, today I Kamil Junaid Putra bin Muhammad Shoham will be presenting on the distillation column of our new project. Okay, firstly I will tell a little bit information about the distillation column. Distillation column is the most common separation technique in the process industry, but it has a drawback, which is the distillation process consume a lot of energy in both cooling and heating the materials. Okay, the definition of distillation is a process where liquid or vapor mixture of two or more chemical components is separated into its fraction of desired purity by using the application and removal of heat. Okay, to put it simply, distillation is a process of correcting the liquid mixture into vapor and then cooling that vapor into liquid back. The purpose of distillation process is used to purify a liquid by separating the components of the liquid mixture. So in distillation process, we use the method of separating mixture based on the difference in the volatilities. Okay, the vapor from the boiling mixture will be richer in components that have lower boiling point. When vapor become cool and condensed, the condensate will contain more volatile component, while the liquid will contain the less volatile component at higher boiling point. In the mixture we use two different chemical components that have different boiling point. So in these two chemical components, the chemical component that have low boiling point will become more volatile, and the chemical component that have high boiling point will become less volatile. Okay, so now I want to talk about the basic principle in the distillation column. So in distillation column, there is three main things that have to be in the process. Okay, the first one is the heater, where we use the heater to heat up the mixture to become vapor, and then we need a condenser to change back the vapor into liquid. And then the most important thing is the mixture must contain two chemical components that have a large difference of boiling point. For the calculation of the number of stages for distillation column, we will use the make-keep tile method. Okay, firstly we have the y-axis and the x-axis, and then we will draw a 45-degree line, and then we will plot equilibrium line that was given in the question. And then for the next step, we must refer to the question to search for the X feed, X boiling, and X distillate, and then plot it at the X axis. Okay, for the next step, we will draw a Q line. For the Q line, there is a condition. Which are for the Q equal to 1 is for boiling point, and then if the value of Q is in between 0 and 1, it is for partially vaporized, and Q equal to 0 is superheated component. Okay, next we will draw the Q line, which we assume this one is Q equal to 1, so we draw a straight line, Q equal to 1. Okay, and then we will draw a rectifying order line. Okay, for rectifying order line, we will first calculate the y-intercept based on the formula given, and then we will draw it from the x-lead until the value of y-intercept that we get in the question. And then For the SOL, which is tripping order line, we will draw it from the intercept of Q line and RL until the XB. Okay, for the next and final step, we will start drawing the stages, which is we just see and let's draw it. Okay, that's all. After finish drawing the stages, we will calculate how many stages we have here and then, which is 3. And then we will minus by 1 because what the first stages is for the revolver.
Okay, Assalamualaikum. Now we jump to the model that we constructed with our teammates. This example for the model bubble cap distillation column. From here, you can see the feed of the product. We start from here to entering the bubble cap distillation column. After the feed is entering the bubble cap distillation column, they will distillate the pure and impure product. The pure product will go to the upper of the bubble cap distillation column and enter into the condenser. The function for the condenser is to turn the vapor product into the liquid product. So the pure will go to the reflux drum and reflux drum do another process and this distillate product will form. For another distillate product, we go to the bottom of this reflux drum and from here you can see the reflux flow from here to here and enter back into the bubble cap distillation column. The lower part for the bubble cap distillation column, we get another product which is the bottom product, and some of the bottom product we go to the boiler to reheat the starter product to enter back the bubble cap distillation column, and the cycle for the distillation column is continue. That's all from us. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ain Shahira and I am going to explain about absorption process. So absorption or gas absorption is a unit operation used in the chemical industry to separate gases by washing or scrubbing a gas mixture with a suitable liquid. And the gas mixture is contacted with the liquid for purposes of professionally dissolving one or more components of gas and to provide solution of them in the liquid. Gas mixture is in the gas and solute, while solute is transferred component. So the purpose of absorption is to obtain or remove the desired component of vapor mixture with the usage of a liquid solvent based on solubility characteristic of component towards the liquid solvent. So next. For liquid inlet, it consists of inlet liquid and little or no solute A. Liquid outlet consists of inlet liquid and absorbed solute A. Note that solute content in liquid phase increase down the column. So for this side, gas inlet consists of inlet gas and solute A, while gas outlet consists of inlet gas and unabsorbed solute A. So solute content in gas phase decrease up the column. So some examples of applications include removal of ammonia and benzene and toluene from coke gas, removal of SO2 from stacked gas, and removal of CO2 from synthesis gas.
Okay, Assalamualaikum. Today I will explain about how to calculate the number of stages in countercurrent multiple contact stages. Okay, this is the absorption column. Okay, the N plus 1 is the vapor inlet and V1 is the vapor outlet. Liquid outlet is L0 and the liquid inlet is L0 and liquid outlet is Ln. So for the stages, we use component A. There are 3 components usually, which is component A, B, and C. But we only use component A. Okay, we need to do the material balance before we draw the graph. We use several formulas. For the before we make the graph, we need to use the formula to do the material balance, which is L0 plus Vn plus 1 equal to Ln plus V1 equal to M. So we add the Y and X, so we got the LO plus XO plus Vn plus 1 Yn plus 1 equal to Ln Xn plus V1 Y1 equal to M Xn. This is the first formula, second formula, and the last one is Yn plus 1 equal to Ln Sn over Vn plus 1 plus V1 Y1 equal minus L0 X0 over Vn plus 1. After we do the material balance, we will do the graph. For the graph, this is mole fraction Y. And this is mole fraction X. So, first we need to do the equilibrium line, and the value of the equilibrium line is given in the question, and we choose 2 points, is P1 and P2. Okay, for P1 we use Y1 and X0, while P2 we use Yn and Xn. So we will get point 1 and point 2. Okay, for the stages, we will do it from the below. Okay, this is the equilibrium line. So we will start by, this is the operating line. We will connect the operating line to the equilibrium line. Okay, so if we want to calculate the stages, the one from the operating line connect to the equilibrium line is 1 stages. So there is 2 stages. Okay, apart from using the graph, you can calculate the number of stages by using formula, which is n equal to log Yn plus 1 minus mx0 over y1 minus mx0 in bracket 1 minus 1 over a plus 1 over A over log N. Whereas A is refers to the absorption factor.
So I will explain about the model we did it with the teammate about this is the packed absorption column. So this is the gas outlet, liquid inlet, liquid outlet and gas inlet. So the liquid will be entered in the liquid inlet and goes out to the liquid outlet. And the gas outlet will be entered the gas inlet and go out to the gas outlet. So the upper layer is the demister pad. After that, this is the liquid distributor. So the type of the liquid distributor is flow multiplier distributor. And then this is the packed bag, which is random packing. So the type of the packed bag is ceramic and metal. And the name of the materials is rest sheet rings, pour ring, burr saddle ceramic and interlock saddle ceramic. So this is the support grip. So the support grip is function to support the layers. And then this is the liquid collector. So the function of liquid collector is to collect the liquid, enter into the liquid redistributor. And the function of liquid distributor is to distribute the liquid from the liquid collector, and then it goes to the packed bag, which is the structure packing. So the structure packing, the type of the structure packing is thin corrugated metal plates or wire gauze. So the function of the structure packing is it gives a big surface area and enhance the spreading of the liquid of the structure packing, and then the liquid will go out in the liquid outlet. That's all. Thank you.